Okay, now that we've looked at a couple of good examples, we're going to discuss a new rule here, Descartes' rule of signs. Descartes was a mathematician that you may enjoy doing a little research on or reading about if you're kind of a math geek like me. What he did is, through his work through polynomials, he just noticed a common pattern start to take place, and he came up with a rule that can basically predict what the sign is going to be of your real roots in a polynomial function, and also how many positive and negative roots we're going to have. And according to the amount of real roots, we could then predict how many imaginary roots a polynomial has. So if you look here at the Descartes rule of signs, it basically tells us this. If we write the polynomial in standard form and count how many times the sign changes, that will tell us how many positive zeros there are, positive real zeros there are in the polynomial. Or it could be less than that amount by an even number. So obviously if we had 3 possible positive roots, or 2 possible positive roots, and we took 2 of those away, those 2 possibilities are then going to the imaginary parts. Now, to figure out the negative roots, what we actually have to do is we have to figure out what f of negative x is. So we have to rewrite this version of the polynomial as f of negative x and then write that in standard form. Again, we'll check the number of sign changes, and that'll tell us the number of negative zeros or roots that we have, as well as that, or 2 less, or less by an even number. Now, we're going to go through an example here and then a sample problem. What I've done is I've provided you with little tables to kind of fill in. They kind of make this process a little bit easier, but you're going to just need to do a couple simple things here whenever we go through this rule of signs. So let's take a look at it. If we come down to example 1, we start off with f of x, 2x to the third minus 5x squared minus 6x plus 4. And as you can see here, just looking at the signs, 2x to the third is a positive number. So going from a positive to negative is not a change in the sign, but negative to a positive is a change in the sign. So that's 1 change, that's 2 changes. So what that tells me is there's possibility of 2 positive real roots, or less than that by an even number, so possibly 2 less. So we could either have 2 positive real roots or 0 positive real roots. Now, to figure out the negative, we need to replace x with negative x, and so we get negative f of x. And you can see here, we have negative, we go from negative to positive there, but then we have positive again. So we only have 1 negative real root, which means to be less than that by an even number would give us to -1, which is not possible. So we know we're going to have exactly 1 negative real root in this problem. So let's take a look how this would play out in a table or a chart. This makes this so much easier. If we have 2 positive real roots, and we know we have exactly 1 negative real root, then we only have 3 total possible roots, so we would have 0 imaginary. So that's one possible scenario. However, if we have 0 positive real roots and 1 negative, then we're going to have 2 imaginary roots to fill out our 3 possible roots. Now, you can graph this on your calculator and verify which one of these 2 possibilities it's going to be. And by doing this, we can really hone in on what our possible zeros or roots or solutions are going to be. So let's take a look at sample problem number 3 real quick. Go ahead and try that process on your own, and then come back and take a look at the answer. Okay, so if we do f of x, we can see we go from positive to negative here, negative to positive there, and then we stop. So that's 2 changes. So that's 2 possible positive roots, or 0. So we can have 2, or we could have 0. So now we need to run the f of x possibilities. f of negative x possibilities. And so we replace x with negative x, and then we just need to consolidate that so that we can see our sign changes. Now that we've finished consolidating it, we can then see our sign changes, which is going to be from a negative to a positive to a negative, and a negative to a positive. That's 3 possible negative roots, or less than that by an even amount. Now, we're dealing with a value, a polynomial that's x to the 5th, so we know that we could have 5 possible roots total. Well, if we have 2 positive and 3 negative, that means we have 0 imaginary roots. However, if we have 0 positive and 1 negative, then we're going to end up with 4 possible imaginary roots. So by doing this at the very beginning of the problem, you tend to give yourself some kind of clues as to what type of roots or zeros or solutions to expect as you work the problem. And as we know, if we know what our answer looks like, that gives us a little bit more confidence as we work the problem. So as we go into the last set of sample problems, you want to use the Descarte rule of sign to help you out from the beginning.